Chapter 30, Section 4, Interactive Reader, pages 485 through 488, 11 points. Stars, galaxies, and the universe, the Big Bang Theory. Key ideas. As you read this section, keep these questions in mind. How did Hubble's discoveries lead to an understanding that the universe is expanding? What is the Big Bang Theory? What evidence supports the Big Bang Theory? Page 485. If an object's spectrum is blue shifted, what can you conclude about the object's motion? What did Hubble discover in the 1920s? What is cosmology? Highlight. The study, the origin, structure, and future of the universe is called cosmology. Scientists who study cosmology are cosmologists. Highlight. Cosmologists study the universe as a whole. Continue highlighting. Astronomers study the parts of the universe such as planets, stars, and galaxies. Cosmologists have theories about how the universe began and how it is changing. They test these theories against new observations. Many of these theories began with observations made less than 100 years ago. How do we know that galaxies move? Highlight. Scientists use light to study the movement of objects in space. Continue highlighting. As an object moves, its light seems to shift on the spectrum toward red or blue, as shown below. Continue highlighting. Blue shift equals the object moving toward Earth. Continue highlighting. Red shift equals the object moving away from Earth. In the early 1900s, the astronomer Edwin Hubble studied spectra from galaxies. His research uncovered information about the universe. Question 1, if an object's spectrum is blue shifted, what can you conclude about the object's motion? It is moving toward Earth. It is moving toward Earth. Measuring redshifts. In the 1920s, highlight, Hubble found that the spectra of distant galaxies are all red-shifted. Hubble used this red shift to highlight, determine how fast the galaxies are moving away from Earth. Hubble found that, highlight, the most distant galaxies show the greatest red shift. Thus, these distant galaxies are, highlight, moving away from the Earth the fastest. Modern telescopes with cameras can take images of spectra. These spectra all confirm Hubble's original observations. Question 2. What did Hubble discover in the 1920s? The most distant galaxies are moving. The most distant galaxies are moving away from Earth the fastest. Away from Earth the fastest. Page 486. Why are distant galaxies moving away from our galaxy more quickly than nearby galaxies are? How does the red shift of distant galaxies support the Big Bang Theory? The expanding universe. Imagine a raisin cake rising in an oven. If you could sit on one raisin, you would see other raisins moving away from you. Raisins that are farther away would move away faster. Highlight. This is because more cake is between you and the distant raisins, and the whole cake is expanding. Continue highlighting. The situation is similar with galaxies and the universe as shown below. Under the diagram, highlight, just like these raisins, distant galaxies move away from the observer faster. Question 3, why are distant galaxies moving away from our galaxy more quickly than nearby galaxies are? Answer, there is more space between Earth and distant galaxies. there is more space between Earth and distant galaxies, and the entire universe is expanding. And the entire universe is expanding. Again, there is more space between Earth and distant galaxies, and the entire universe is expanding. What is the Big Bang Theory? Cosmologists have offered different theories to explain why the universe is expanding. Highlight. The current and most accepted theory is the Big Bang Theory. Continue highlighting. This theory states that all matter and energy in the universe was once compressed into a very small space. Continue highlighting. About 14 billion years ago, a sudden event called the Big Bang happened. Continue highlighting. The Big Bang sent all matter and energy outward in all directions. Continue highlighting. As a result, the universe expanded. Some of the matter came together in clumps, which evolved into galaxies. Today, the universe is still expanding. Highlight. The galaxies continue to move apart from each other. Continue highlighting. This expansion explains the red shift of distant galaxies. Question 4. How does the red shift of distant galaxies support the Big Bang Theory? Answer. The galaxies that were created during the Big Bang are still moving apart. Due to the original expansion. Again, the galaxies that were created during the Big Bang are still moving apart due to the original expansion. Page 487. Why is the cosmic background radiation uneven in some places? How do scientists detect dark matter? Ripples in space. Satellite maps of cosmic background radiation show ripples in temperature. These ripples, highlight, show that cosmic background radiation is uneven in some places. Continue highlighting. This is because matter was not spread evenly in the universe. Continue highlighting. The ripples show the early stages of the universe's first galaxies. Question 5. Why is cosmic background radiation uneven in some places? Matter was not spread evenly. In the early universe. Again, matter was not spread evenly in the early universe. What materials make up the universe? Astronomers are continuing to research ripples in cosmic background radiation. They are also studying distances to supernovas in ancient galaxies. Highlight. This research has helped astronomers learn more about the structure of the universe. Continue highlighting. Astronomers now think that the universe is made of more mass and energy than they can detect. Dark matter. The ripples in cosmic background radiation show, highlight, that the universe may contain different types of matter. Continue highlighting. Regular visible matter makes up only 4% of the universe. Continue highlighting. Another 23% of the universe is made of dark matter. Continue highlighting. Dark matter does not emit or reflect light, but scientists can detect its gravity. Question 6. How do scientists detect dark matter? Answer. It's gravity. Again, it's gravity. Dark energy. Highlight. Research also shows that most of the universe is made of an unknown material called dark energy. Continue highlighting. Dark energy acts as a force against gravity. Scientists think that, highlight, some form of dark energy is pushing galaxies apart. Continue highlighting. Dark energy is causing the universe to expand faster and faster. In the image, 4% of material is made of atoms, 23% dark matter, 73% dark energy. Page 488. How is cosmology different from astronomy? Describe Edwin Hubble's observations and explain how they show that the universe is expanding. In your own words, describe the Big Bang Theory for the origin of the universe. How does the Big Bang Theory explain the existence of cosmic background radiation? How is dark matter different from regular matter? How are they similar? Question 1, answer can be found on page 485. Cosmology studies the entire universe and its origins. Again, cosmology studies the entire universe and its origins. Astronomy studies parts of the universe. Astronomy studies parts of the universe. Again, cosmology studies the entire universe and its origins. Astronomy studies parts of the universe. Question 2, answer can be found on page 485. Hubble showed that distant galaxies were shifting faster. Hubble showed that distant galaxies were shifting faster toward red, meaning they were moving away from, toward red, meaning they were moving away from, Earth faster, and the universe is expanding. Earth faster, and the universe is expanding. Again, Hubble showed that distant galaxies were shifting faster toward red, meaning they were moving away from Earth faster, and the universe is expanding. Question 3, answer, all matter and energy moved outward. All matter and energy moved outward from a dense ball, to form the universe. Again, all matter and energy moved outward from a dense ball to form the universe. Question 4, answer can be found on page 486. The radiation can be found in all directions. The radiation can be found in all directions. Question 5, answer can be found on page 487. Dark matter cannot be detected. Dark matter cannot be detected. Regular matter can be detected. Regular matter can be detected. Both dark and regular matter have gravity. Both dark and regular matter have gravity.